Hello, wonderful students. Thanks for taking a look at this. Research has shown that being able to look at an exam before taking it helps with anxiety. So I decided that we would look at the problems today together and just look at them, okay? Remember those skills, review those skills, reach out to me if you don't know how. I might talk about some trip steps, but I'm going to try to make this fairly short so that you can, this is open, so you can either try this slowly, you get one attempt, but that way you just have time, right? So let's fingers crossed, we can do this. This is my second take. So here we go. I'm going to zoom in. I'm going to move this up to here for now. I got to zoom in on the screen. All right, so this is subtracting polynomials. You can pause it if you'd like. It's variation 1, variation 2, variation 3. Key trip steps would be, because of this subtraction symbol, we need to distribute it to each term. Okay? Next, you need to combine like terms correctly. So remember, you're looking for the variables that are exactly the same kind of variable, same power, and then you can add or subtract the coefficients. Think about those invisible ones or negative ones when you add and subtract. But if you don't have one, like take a look at this one, look over here, then it just stays. It just stays within your polynomial. All right, hopefully that helps. That's question 1. Not too bad, not too much time. Okay, which graph represents this inequality? The reason I have Desmos up here is because graph it, friends. Take a look at that and graph it. So we're not going to graph that one. Why are you following me? Down here will help you if you ever get stuck with the keyboard. See these symbols? Sometimes you don't know where those symbols are, so that's why this video is here too. Boop. We have 4x plus 3y greater than or equal to 9. Oop, well, okay, well now that didn't help you either. Well, come over here. All right, zoom out. Maybe now we move it, right? We can drag it around. I just click and drag. I can zoom back in because those numbers are pretty big. Look at the axes. Look at the labels. What does it mean? Still too big, way too big. I'm zooming in so it's more realistic. Okay, that's much better. But anyway, so you can zoom. So now you can kind of see whatever your graph is, what it would look like. Also take some time and explore here. What if you had it the other direction? What if it was, so I just clicked in here and oh, look at that. What if it was just strictly less than just this one? See what's happening with these graphs. Pay attention to what this means. Look how that's over there. Well, would it change if I did 9 and I kept the big mouth, see how the big mouth, and then said 4x plus 3y? Oh, look at that. The blue is right at the same spot as the red. It just looks different. Use this to explore those ideas. Type them in here, see what you see, helps you solve on your graphs, okay? Which graph represents this inequality? Using tools appropriately and strategically is a wonderful skill. Desmos, what a great company and program to help us explore math. So, again, use these tools strategically and appropriately. You're using lots of skills here. Lots of skills. How to use the tech. What does this do? What does the math do? How to write this correctly. How to zoom in and zoom out so that it makes sense. Checking our work. They never do the thinking for us. Technology by they, not robots or anything. What are the roots of this equation? Okay. Let's see what happens if I type this into Desmos or a variation of this. So I'm going to get rid of these. What was it? X squared. Look, what does this do? X squared minus x. Okay. But then it said equals 15, let's just do equals 16. What in the world? It gave you 2 lines. 2 lines. That doesn't make any sense. Well, that's because you had it graph an equality, not a function. And we'll talk more about that next unit. So we would put this in what we remember standard form. So we'd bring it back over, put it in standard form for a parabola. So if it's positive 16 on the one side of the equal sign, it would become negative 16. And there we go. We have it in a different form. Let me lower this. See this lovely parabola? But the roots are the same. The roots are the same. Okay? Okay. You might solve this, and I'm not saying that you would. So if I solved this, you could get some sort of radical number. Okay, I'm trying to do the quadratic formula in my head. That just doesn't work. But notice if you got something like 4 root 5, it'll tell you what it's equal to. So you can type in your answer. It'll spit out what it's equal to. Maybe you got 1 minus, and technology tools. How am I doing on that? Keeping it short and sweet, huh? 1 minus, you'll get a different number, but you can try your answer and then see if it matches your graph. So these are just checking ideas. This is not the correct answer to this quadratic equation, but it's just showing you a different way to use this tool to check both the graphically and algebraically if the answer you got was correct, or if some of the answer choices are correct. Okay? All right, so you're going to try to find the roots of this equation. Several options. You could factor. You could put it in standard form, use the quadratic formula. You could put it in standard form, remember setting it equal to 0, and graph it. Okay? Okay. We're going to go a little bit faster. Yay! All right, there you go. So, however you want to solve it, graphically, quadratic formula, try factoring, it's up to you. Notice this is not a 1. So you'd have to do that thing where you do 7 times 5 and then try to split it. I would just use the quadratic formula, but if it's not your strong suit, that's okay. Reach out to me too. Solve the system of equations using the substitution method. Well, that's wonderful. They would like for you to use the substitution method. I would like for you to use the substitution method. If ever you get stuck, Khan Academy is quite amazing and organized videos. Check them out. Type in substitution method or this whole entire thing. This won't copy very well. So when you do this, if you try to copy the whole thing to just get an answer, it's going to be a mess. But you could use Khan Academy and search for videos that you could follow along in the steps. Notice how this is x is equal to this. Substitute that whole expression into here. Review our videos. We have these. Y, it's already solved for y. You could substitute this whole expression into y for here. Then distribute, combine like terms. Wonderful skills. You've got this. System substitution method. Okay? Okay. Simplifying radicals, Unit 2. Remember, we need to look for 32 factors, see if there's any perfect squares. 20, see if there's any perfect squares, see what you're left with, and then if you have the exact same radical, right, if the exact same radical is left under here, then you combine them and keep going. If it's not, then leave it, right? If this is like 2 root 5 and this is 2 root 2, just say 2 root 5 plus 2 root 2. That's okay. I don't actually know what it is and didn't do it right away. I'm trying to see if they're common or similarly, right? However it simplifies, use those skills, simplify it completely. When it says to simplify, it's asking you to see if there's any perfect squares in the number underneath the radical, and go ahead and take the square root and then pull them out of the radical. We've done that. You guys have got this. Well, you had a little bit of a preview. Remember, the denominator is the root. The denominator is the root. The numerator is the exponent. The numerator is the exponent, and it distributes across these terms. Okay, so you're going to have question 7 is a variation somewhat like that. See? Root, distribute, and it'll be in radical form. Radical form. So on your school keyboard, you're going to need to use the one, here now I need to show you this, the one that has the little box and the big box. You're going to need to put the root there, the denominator, and you're going to need to distribute the numerator, the exponent, to get the fully whatever term inside of here. Other exams and example problems, they accept it in parentheses with the square, but I doubt this one will. It really should. It really, really should. It should be both. But so remember to distribute the numerator to each term using rules of exponents. You multiply 4 times 3. Okay. Look out for those whole numbers, right? If it's 5 squared, we'll square it. 5 times 5 is 25. If it's 2 to the 4th power, we'll do it. It's 2 times 2 times 2 times 2, which is 16. Okay, multiplying complex numbers. We did this. This was part of the Unit 2 TGA. You multiplied complex numbers and then you subtracted a complex number. So you can do this. Use FOIL. The only step is to remember I squared is equal to -1. Okay. What is the product? Vocabulary word product means multiplication. Standard form. I'm glad we scrolled down. Standard form is this. You put the real part first, A, then you put the imaginary part second, plus BI. This entire thing is the imaginary part. This entire thing is the real part. Awesome, you guys. Adding polynomials. Just combine like terms. Okay, I'm not going to look at any more. Adding polynomials. You can do it. Factoring. Ooh, can we? Let me see. Ooh, I don't know. That's a hard one, huh? What's there? B, A, 2A grouping. I'm looking for grouping. Yeah. Look for common factors. See what you see. See what happens. And good luck. Okay. The sigh is just because why would we not have that together as part of one of our homework problems on the homework quizzes? They are in your practice course problems though, friends, which is why I ask that you complete them, at least look at them, look through them, look at the solutions, look at the worked examples. Extra practice problems are right there, always available in each of your lessons. Okay, I'm going to pick up the pace because this is 40 questions. This is a compound inequality. The steps for solving you just do to both sides till you get x by itself. You need to be careful of that trip step of when you multiply by a negative or divide by a negative, you flip the signs. But you got this, okay? Compound inequality. There's again help videos. Very fancy. What do you think to do? Boop, boop. You got this, okay? Solve for x. Questions 11 and 12, solving for x. One will have multiple answers, one won't. Pay attention to negatives. Solve just like normal. Factor over the complex numbers. We just did this today. I'm making this video at the end of the day to try to help you guys think about what we've learned, how much we've learned, so much to it. Take your time, use your notes, pause, take a break, come back to it, okay? Factor over the complex numbers. You've got this. This one is not a square, though, a sum of squares. 52, not that I know of. Can you think of anything? 2, 50, 21, 27, 26? No. Okay. So I like to solve for the roots and then set them in factored form. Check out those notes, 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 notes. Which expression rationalizing the denominator? We're going to multiply by a clever name for 1. Take a look at that denominator. Yep, you betcha. What did they do differently to us this time, though? 50 is not in simplest form. So you're going to need to check. 45 is not in simplest form. So they're probably having you rationalize the denominator and then simplify it. I don't know. I haven't seen the solutions. 12 is not in simplest form. They might not. They might just be having you multiply it by a clever name for 1. So if you had 1 over the square root of 10, no, 20, that's a crazy square root. You would just multiply by 20 over 20. When I was in school, I would just remember that, oh, okay, if I do this, I just know I flip that up in there and take away the radical sign. I didn't know why. I just knew that rationalizing the denominator meant I took away the square root. I added the square root up here. Oops. Took away the square root for our problem, the 20. I added the square root up here, and then I put whatever number was with it in front of it. And then I was done. That was the extent of my understanding of what was going on when I rationalized the denominator. But really what's happening is you're taking the square root and you're making a clever name for 1, and 1 times anything is itself, so we're not changing the answer. We're not changing what it equals. We're keeping it equal. We're just using this property that a square root times the same exact square root is the number underneath the radical. That's what we're doing. That's what's happening. We can't just magically take the square root and add it up there, but this is what we're doing. Okay, if you had a number here, 4, you would leave that number here, but then you might have to simplify, right? 4/20 simplifies to what, 1/5? So you would end up with root 20 over 5, and you may or may not have to simplify the 20. The radical, simplifying radicals. Okay. One of the reasons we do that is because of the quadratic formula. Word problems. Oops. Ooh, no, I just want to move this. Word problems. Linear programming. Okay. Oh, cool. It's just asking for another constraint. Read the problem, see what restrictions they have. What actual restrictions, if they were trying to solve this in real life, what limits to something? Okay? There are limits when we work in real life. Limits to our time, limits to all sorts of stuff. Go away. Okay? Linear programming. Woo! Multiplying, FOIL, you've got this. Simplifying complex numbers, you've got this. Just like combining like terms. Just again, that trip step. Don't forget about that negative, right? Nothing is being multiplied. That's a freebie. It's a freebie. I'm going to stop there. Nothing is being, I don't know why I did that. It just shot down there for you. Okay? Solve the system of equations using the linear combination method. It's not really free. If you're watching the video all the way through to this point, you deserved it. 2x minus 5y equals negative 1. Solve the system of equations. So we got to keep going. Linear combination method. This one is a little bit different. I would Google it to watch it again or check your Unit 1 notes. Watch some Khan Academy, see what's going on. Check by graphing. Okay, check by graphing. Linear combination. That's a good way to use Khan Academy with those help videos, their example problems. It's pretty cool. And then also Tutor Me. Don't use Tutor Me for this though. What number needs to be added to both sides of the equation to complete the square? What a great question. What is b? What is half of b? What is half of b squared? This is not an even number, so it's not going to be a nice, neat number. That's not an even number, so it's going to be a fraction. Okay, tip and trick. When squaring a fraction, if you square it, you have to square the numerator and the denominator. And that makes sense, right? Because if I have a over b times a over b, that is how we multiply fractions. A times b, a times a, b times b. So, again, be careful. Be careful. Be careful. It's also a negative symbol, but what happens a negative times negative when you square a negative? Solve for x however you want. Doesn't tell you how. Quadratic formula, graphing, trying to factor. Solve for x. You can do it. Halfway done. Let's keep going. Ooh, Marshall uses a polynomial identity this to show that 8 squared equals 64. What values can Marshall use for x and y? Okay, so as your teacher, part of what I use is this curriculum, and I assume that it is standardized pretty similarly, and so that when you get to the interim checkpoint, it's not new ideas that we haven't necessarily highlighted. This is a very awesome thinking question. Okay, what values can Marshall use for x and y? I'm just debating whether or not to scroll down and talk about this one. Okay. Eight squared is equal to 64. We have this right here, x minus y squared. That's interesting. So then according to this statement, 8 squared, what do you think x minus y should be equal to if this is the problem that they're asking us to solve? Okay, I'm going to stop here for the first half of a little past our first half of our interim checkpoint. So you got this. You really do. Apply these same detective skills, all those great questions. When you're on a test, ask those questions. What are they asking of me here? What do I see? What patterns in my reasoning? What similarities? If there's an equal, there's a square. Well, there's an equal, there's a square. And then look at the solutions and see if the solutions help you kind of piece together the rest of it, okay? Okay, now I gotta find, where is my stop sharing? There it is. Okay, thanks for watching.